Good evening, friends. Now I want to explain about the in chemical bonding about Vander Wal forces. Now I want to explain about Vander Wal's forces. What is Vander Wal forces? The intermolecular forces of attraction between the molecules is called as a Vander Wal forces. If you take any intermolecular force of attraction between the molecule, is considered as a Vander Waals forces. Generally, how many types of forces are exist? For example, if you take, there are two different types. One is strong forces, weak forces. There are two types of forces. One is strong forces and weak forces. First one is ionic bond and covalent bond between the atoms exist. These are so strong forces. Nearly the amount of energy required is 200 kilojoule for more, like this. In case of weak forces, one is hydrogen bonding, second one is Vander Waals forces. Vander Waals forces. In this case, hydrogen for Vander Waals forces approximately less than 8 kilojoule per mole existed. In case of hydrogen bonding, greater than 8 to 40 kilojoule per mole energy will be released during the formation of these bonds. With ionic bond, these are strong forces exist, and ionic bond and covalent bond. Weak forces are existed in the hydrogen bonding and Vander Waals forces. What is the sequence of the priority of the first one is ionic bond is stronger bond greater than covalent bond. Next, hydrogen bond. Least one is Vander Waals forces or bond. This is the sequence of the different type of bonds and different forces between the molecules. These points you have to remember before discuss with the Vander Waals forces. Next, we discuss about the types of Vander Waals forces. General definition of Vander Waals forces between the intermolecular forces of attraction between the molecules is called Vander Waals forces. Vander Waals bond will form the Vander Waals forces. This is the definition of the Vander Waals force. Next we discuss about the which molecule will show the Vander Waals force. Vander Waals forces exist in between ion and ion, ion and dipole, dipole and dipole. Like these molecules will show the Vander Waals forces. Okay. If you take any ion and ion dipole, the molecule then show the, in case of polar and also non-polar molecules also will show the Vander Waals forces. Next we discuss about the different types of van der Waal forces. Types of van der Waal forces. First one is ion dipole. First one is ion dipole. Ion, if you take any Cl minus, dipole means if you take any HBr, due to the electronegative difference, they will form the positive dipole, here a negative dipole. The forces of attraction between positively and negatively charged is called ion dipole interactions. These interactions are called ion dipole interactions. Due to this, Cl minus dipole means this is polar molecule. If you take second one, which one? Dipole interactions. Dipole interactions. If you take any polar molecule, two polar molecule, for example HBr and also take HBr, due to this electronegativity difference, here it form delta minus. Due to this electronegativity difference, this will form delta plus. Between these two molecules also, this is a polar molecule, this is also polar molecule. This will form due to dipole interactions. It will form the van der Waal forces. This is second type. Next you take third one. Ion and induced dipole. Induced dipole molecule. If you take any ion, either take Cl minus. Induced dipole means if you take non-polar molecule, for example hydrogen, this is a non-polar molecule. What will happen? Due to this Cl minus negative charge, these electrons, this bond attract the electrons towards this side, then it will form the delta plus and here form the delta minus. That is called ion induced dipole moment. Ion induced dipole moment. Either you take Na plus oxygen O double bond O molecule. This is a non-polar molecule. Due to this positive charge, here attract, here it form negative charge, here it form dipole exists. Due to the electrons donate sodium plus ion. That's why this is ion. Due to this ion induces the dipole nature between the oxygen molecule. Then it is called as a ion induced dipole interactions. One is first one ion dipole. Next ion and induced dipole. Next fourth one dipole and induced dipole attractions. Next one is dipole and induced dipole. Dipole and induced dipole. Induced dipole extractions. For example, if you take HCl, you take chlorine and chlorine. Due to this electronegative difference, chlorine is more electronegative, that's why it attract delta minus. This will show delta plus. Here, due to this delta minus negative charge, this attract this chlorine towards itself. Then it automatically form positive charge and it shows negative charge. Due to this dipole, this is polar molecule, this is non-polar. Due to this dipole, it induces the dipole nature of the non-polar molecule. Then this is called as a dipole induced dipole attractions. Next fifth one is next instantaneous dipole and induced dipole. This is very, very important. Instantaneous dipole and induced dipole. Instantaneous dipole and induced dipole. For example, if you take hydrogen molecule, if you take hydrogen molecule, in this case what will happen, if you take the electrons, maybe you have to identify somewhere, automatically opposite side charges, another place it will show positive charge. If you take another hydrogen molecule, due to this positive, it will attract the electrons of this hydrogen molecule towards its induces. Due to this positive charge, it induces the attract the electrons. That's why here you get delta electrons, and you also get positive charge. This is known as a instantaneous dipole, and is this hydrogen molecule induces this hydrogen molecule to dipole nature. That's why this is called as a instantaneous dipole and induced dipole. These are the 5 types of van der Waals forces of attractions. One is ion dipole interactions, next dipole interactions, next ion induced dipole interactions, next dipole induced dipole, instantaneous dipole and induced dipole. The priority also, the forces of attractions between the priority is 1 is greater than, 2 is greater than, 3 is greater than, 4 is greater than 5. These examples you have to remember. I will give you some of the examples. For example, if you take Cl minus, that is HBr, next Br minus, next hydrogen, next and O2, which is more? First example, which one is more? This is ion dipole, this is non-ion dipole. Next, this is ion induced dipole, this is instantaneous dipole and induced dipole. Which one is greater? This one is greater than, this one is greater than this. That's one, because ion dipole is strong attraction, strong van der Waals forces compared to ion induced dipole and instantaneous dipole and induced dipole. This is the one of the example. Next, how to take next HCl and HCl, next Cl minus CCl4, next hydrogen HBr. Which one is greater? This is dipole, because these two are electronic difference. This is get negative charge, this is get positive charge. That's why this is dipole interactions. This is ion and induced dipole. Due to this ion, it will get the induced dipole. This is non-polar nature. Polar and non-polar. Non-polar, ion induced. This is dipole and induced dipole, because this is polar, Br minus delta plus. Next, which is greater? Dipole is greater. Next, ion induced, after that this one. Next, if you take in the vessel, you take here fluorine, here chlorine, here bromine, and iodine. Two different molecules you have to take it. This is what? Instantaneous induced dipole. If you take two are non-polar molecules, because their electronegativity is same. Generally, van der Waals force of attraction is directly proportional to the molecular weight. Which is more molecular weight? Fluorine, chlorine, bromine, iodine. That's why the van der Waals forces of attraction between iodine is greater compared to these two are gases, this is liquid, this is solid in nature. Van der Wal forces of attraction is generally directly proportional to the molecular weight. That's why fluorine, fluorine, chlorine, chlorine, bromine, bromine, iodine, iodine. We take one vessel. Which forces are greater? That is iodine, because due to molecular forces of due to atomic weight. More atomic weight, more will be the molecular forces of attractions. Next, I have to take some of the examples. Next, we have to take boiling point of noble gases. Next we take organic molecule. For example, this is N-pentane. Next, if we take this is isopentane. Next, this is neopentane, which will show having maximum van der Wal forces of attractions. In this case, van der Wal forces of attraction is directly proportional to surface area. This is one of the example. If it is more surface area, then it will be the more exhibit van der Wal forces of attractions. In case of N-pentane occupies more space, that's why more surface area. N-pentane is greater than, next isopentane is occupied more. Next isopentane more van der Wal force of attraction. Next greater than neopentane. This is also you have to remember. Occupies more space, it will exhibit the more van der Wal force of attractions. This is one of the. Next you take HF, HCl, HBr and HI, which will having more van der Wal forces of attractions. Generally, before this I told you, van der Wal forces of attractions directly proportional to molecular weight. This is I have told. According to this, the molecular weight of HI is greater. This is the, according to that, but this will not. This is not the series, correct? This due to this HF it will be highest compared to this series, because HF will form the hydrogen bonding. Hydrogen bonding is stronger bond compared to van der Wal force of attractions. Van der Wal forces of hydrogen, due to hydrogen bonding, this is greater compared to HI. This is the correct series. In case of due to this hydrogen bonding, this will show the highest van der Wal force of attractions compared to the HCl, HBr and HI. Similar series here also, H2O, H2S, selenium and also tellurium. Here also van der Wal forces of, according to van der Wal forces of attraction is directly proportional to molecular weight, but due to this, according to this, but due to hydrogen bonding, this will show the highest. Correct series is, this is wrong. Correct series is H2S greater than, H2S is greater than, H2T is greater than water. This is the correct series in the their van der Wal forces of attractions. This point also you have to remember. Next, if you take one of the important rule that also you have to remember. This is the important concept. Definitely one. In case of lithium, beryllium and magnesium, aluminum, these are the metals. In case of chlorine, bromine, iodine. These are the non-metals. This will form first aluminum AlCl3, ArBr3, Al(I3). Next, we take how the molecule will form. Next, beryllium Cl2, beryllium Br2, beryllium I2. Next, magnesium Cl2, magnesium Br2, magnesium I2. Next, lithium chlorine, lithium bromide, and lithium iodide, which will having the highest Van der Wal forces for attraction according to. Before this, we discussed Van der Wal force of attraction is equal directly proportional to molecular weight according to the our law. But in these cases, exceptions are there. Exception, not like that. According to this, this is the maximum. Same like this also. Due to lithium iodide, magnesium iodide, highest molecular weight. But this is wrong. This is not applicable to here. Why? Because in this case, in these metals and non-metals case, bond formation, the Van der Wal forces of attraction is directly proportional to bond polarity. Directly proportional to bond polarity. Depends upon bond polarity. Bond polarity depends upon which is having more polar. Due to this more electronegative nature, more electronegative difference, this is having the highest bond polarity. That's why AlCl3 is greater than AlBr3 is greater than Al(I3). This is the correct one. Same similar to here also. Here, due to the electronegativity difference, this is the correct one. This is the correct one. Because why? Because bond polarity. Bond polarity depends upon difference in electronegativity. This magnesium chloride electronegativity difference is more compared to magnesium chloride and magnesium iodide. Here also lithium chloride electronegativity more compared to lithium chloride and lithium chloride. These points you have to remember. This case is not applicable here. Only this one is applicable. This you have to remove. In case of exceptions, lithium, beryllium, magnesium, and aluminum. These are the metals. Non-metals, chlorine, bromine, and iodine. In this case only it is applicable. Then this is about the Van der Wal forces of attractions. Next we will discuss completed this chapter.